Hello friends, welcome to another tutorial of EOBIM parametric modeling and C# scripting channel. Today I'm going to be showing you a C# script for creating walls out of a 2D drawing created in AutoCAD. We're going to create a 2D drawing in AutoCAD. We're going to import it to Revit, and then we're going to place walls in those lines. So let's get started. First, for the first step of this tutorial, we're going to create a bunch of lines for this script, and we're going to create the lines in a very specific manner. It's important to say that in order to automate your processes, you need to plan how are you going to get the data and how are you going to execute the scripts according to the data that you are planning. In this case, I'm going to make a very simple plan for drawing these walls. I am going just to create two kinds of lines. I'm going to create an external line with this boundary tool, an external line, and an internal line. Look at this. I'm going to make an offset of 0.6 meters. I'm going to make this a bit exaggerate, only in order to show you clearly the effect of the script. And I'm going to create two layers. I'm going to create a first layer that is going to be called interior, and I'm going to create a second layer that's going to be called exterior. I'm going to give very different and clear colors to these layers in order to differentiate them, and then I am almost done. I just have to place the lines in its respective layer, and we are almost set up. I'm going to save this file to my desired path, to my desired location. I'm going to use, I don't know, yeah, in document is fine. I'm going to be calling this drawing tree, it doesn't matter really. I'm going to close this file. Yes, I want to save changes. I want to make a new file. Perfect. And now we're going to try a bit more difficult line. I'm going to start in the 0.0 point, but now I am going to create a quite moved line. Yeah, this is fine. I'm going to make an offset of 0.8 meters only to show you. Of course, in a real plan, this will be an offset of the thickness of the wall. But in this case, as I said before, we're going to just do this for didactic purposes. An internal layer and an external layer. I'm going to put the colors. I think the colors really doesn't matter. The colors are only to help us see the difference. External, internal. Notice here I named them backwards. This shouldn't be, because we're going to be placing the walls in the incorrect layer. Internal, so we can rename this. Yeah. External. Okay, now we can get internal. And we are almost set up. We close here. This is the internal wall. and this is the external. Okay, perfect. We save this file. This is going to be drawing 4. Excellent. And now we're going to make a third file. I want you to show the power of this kind of scripts. Maybe you already can notice the power of it, but I want to really display it. Let's do a line in this place, and let's do, yeah, a bunch of arcs, so you can see the greatness of this. Yeah, another arc of 3 points will be fine, and another arc over here, and another arc over here. I would like it to be, yeah. We create a boundary with these lines. Perfect. Okay, going to delete the single lines, so to keep only the boundary, and make an offset of 0.4 in this case to the internal side. Now it says send working 0.4, 0.6 for some, yeah, it's too big. Well, let's try with 0.2. No, this is not going to work. We need to scale this up. Scale, yeah. Scale it quite a bit, so we can do that offset of 0.4 at least. Yeah, we're done. Here we follow the same process. One layer called internal and another layer called external. Internal is red. Great. External is green. Of course, you can go ahead over all of these repetitive steps. I'm just trying to show you all the steps of this process, but you can move forward in the video. So we save here. This will be our drawing 5. We're just going to use the 5 that I mentioned. Now I'm going to open a Revit file. We're here in Revit, and here we're going to create a new project, metric architectural template. Metric architectural template. Yeah, we create it, and here we're going to import all of those files. Insert, import CAD. We're going to find the files, drawing 3. We're going to import it as meters. We open the file, there it is. Again, import CAD. We're going to find drawing 4, open, there it is also, and we repeat the same process. Import CAD, import drawing 5, meters, open, perfect. So they are currently pinned. We're going to unpin it. Perfect. Now we can move it. We're going to place one over here and this one over here. Perfect. And we are going to select all of them, and we're going to explode them. Explode them. Full explode them. Full explode. Excellent. Full explode over here also, and full explode. So when we explode this drawing that comes as a block, as a group, we found out that each line is individual, and they have a very interesting parameter that is called line style. Here Revit understands the layer parameter that we bring from AutoCAD as a line style. And this is very important because this is a custom, a very specific parameter that we can use to filter specific lines. For example, the external line is external line style because of the setting that we made in AutoCAD. Of course, you can fine-tune this as much as you want. but I just used this purpose for this very simple tutorial. So this is what we are going to use to differentiate between internal lines and external lines in order to set up the wall. And this is going to be useful to define in which place of the perimeter of the rooms, of the spaces, we are going to place the walls. As you know, when we place a wall in Revit, we can place it in the wall center line, we can place it in the core of the center line, and we can place it in the exterior finished face. So this is going to be very important, because with these settings we're going to be able to place the walls. And if this space between the two lines is equal to the thickness of the wall, we can be very precise on how to place walls with an accurate drawing from AutoCAD. So this is what we're going to do. Now I am going to open Visual Studio. I'm going to open Visual Studio to create a new project. We're going to create a project based on .NET Framework. .NET Framework 4.8. This is very important. We are going to create a class library. Great. Not any class library. You have to be very specific. Class library based on .NET Framework with C#, not with this. With C#. Yeah, you select it, you hit next, and you find the folder in which you want to place it. In my case, I am going to place it in my folder, and I'm going to place it over here. Okay. The project will be called Select Lines, Place Walls. That's great. Create, we hit create for the project, and it will create the project. Open the Visual Studio interface for us. Perfect. I'm going to extend the Solution Explorer, and here I'm going to rename the class. I'm going to name the class Select Lines and Create Walls to avoid conflict with the namespace. This is the namespace over here. So I'm going to make it a bit different. The first thing we're going to do always is to create a reference. Right click, add reference. We're going to reference the Revit API. You can hit here in browse, but the browse button, you're going to go to your local disk, you're going to go to program files, Autodesk. And in Autodesk, you're going to go to Revit 2023, and you're going to find the Revit API DLL. You're going to check that out, and Revit API UI DLL. And then they are going to appear over here. You hit OK, and this is going to incorporate these two DLLs. These DLLs are the place where the Revit API classes are stored. There are many more DLLs, but these are the ones that you're going to use. You have to select them then, and now you're going to have to open the properties of that reference and set copy local to false. Because if you don't set it to false, it's going to copy all of that DLL into your script, and it's going to add a unnecessary storing requirement. It's going to copy us 100 megabytes, something like that. So you set it to false, and we are set up. You can collapse this menu, and we are going to create our code. As usual, I am going to search for the template that I use frequently, just to make things quicker. This is, of course, using GitHub. I search for EOBIM, external command boilerplate. or EOBIM, you enter into my account, and here you're going to find this file. At the end of the file, I am going very quick because this I have repeated in other videos, so I don't want to repeat myself too much. You're going to copy the template for the external command. You're going to paste it here. I like to paste it in this way, and change the external command, the namespace, for the correct namespace. Okay, paste it over here and put the right class name over here. You probably know all of this. Maybe you already understand all of these classes. So I am not going to. I have talked about this in other videos, so I am not going to take time to do this. So once that you have done this, you save the project and you build it. Ctrl+Shift+B in order to build the project, and now you can go to Revit, and from Revit, in the Add-ins tab, in the Add-in Manager, manual mode, you can load the external command. You find the folder. I'm going to go for EOBIM and find the location. You're going to find a folder called BIM. There you enter, you go to the debug folder, and there you're going to find the DLL. This is the DLL, and you run it. And that template shows you that the script is working. Okay, you close it. Let's go back to Visual Studio to continue coding. Okay, we're set up. I'm going to, I like very much to create these separation lines because I think it's a bit easier to see the code when you actually differentiate each part. So we're fine over here. I'm going to hide all of this, and we're going to start the script. Let me locate over here my reference document so I can go a bit quicker. The first thing I'm going to do for this script is to create a variable that contains the kind of line that I'm going to select. This is only a string. I will say world type equals to, and you're going to type here internal or external. I mean, if you want to select the external line, you type this, and if you want the internal, you type internal. It's only that. It's only to specify that. So for now, I'm going to select only, I'm going to write, internal. And that's the first step of the script. The second step is to collect the lines, right? The first thing we have to do is collect the line. So the first thing we're going to do is a filtered element collector called line collector equals to new filtered element collector in the document, right? Document, we specified it over here. It's the current document in our user interface, in our Revit user interface. But here the things are going to get interesting. I'm going to zoom up the screen so we can see it. Instead of creating a filter element collector, we're going to specify that this filter element collector have to collect a very specific set of elements. We're going to say that this filter element collector has to collect elements of a specific category. I'm sorry, here my Visual Studio. I'm going to hit dot to access the methods of filter element collector. I'm going to put it in the line below. I'm going to say of category How did I know that of category was a valid method? Of course, I found it on the Revit API. I like to use this .csm file that comes with the Revit API, or you can find it on the internet in this website, revitapidocs.com. You go, you find filtered element collector class, and there, when you go to members, you find its methods, and there you find this method of category. You see it, right? Of category, and you have to pass in a built-in category. When you find what is a built-in category, you will find that it is an enumeration. An enumeration is the end of the path in a path in the Revit API. So you will have to write, this will be the final step of this line. You will have to write built in category, and then specify inside of that enumeration which is the built-in category. You will write OST lines. This will be the built-in category. Perfect. Now this will select all the lines in the document, and let's do a try. We already, with this script, we already have selected all the lines, I think, in the opened document. So let's select the line category and let's display its content inside of the task dialog of the script. Line collector count, let's see how many lines it collects, count, and we say toString because the main instruction of a task dialog is a string. It won't allow you to pass any other kind of data. We compile the script and we open it from Revit. We will have, here we have 4 lines, here we have 4 more, we have 8, and here we have a bunch of them. I think that we will have more than 16, something like that. It's between 15 and 20. So let's see. I'm going to run the script, and well, this is much more. Of course, yeah, we have a bunch of lines, but I only counted the external. We have to double that. We have 19 red lines and 20 green lines. This is perfect. Now we know that we have collected all the lines. And now we have to do another steps. We already have the lines, but now we want to filter. I just want to collect the red lines, the internal lines. So how can we do that? Well, perfect. The next step to filter those lines is to narrow down this search. We have to make this filter more specific. And how we're going to do that? Where we're going to use another method of the filter element collector. Filter element collector is your best friend in the Revit API. And we're going to use the where passes method. This method allows you to pass a filter, a specific, a custom filter to this query over here. Again, how does we know what method to pass in over here? Well, we can go back to the filtered element collector class. We can search for its members. We find that it has a where passes method. We enter that method and we've seen that it takes an element filter. So we have to give the filter element collector class a element filter. Let's see what is an element filter. An element filter is of course a filter, but one of 3 kinds of filters. You have to enter one of these 3 filters. If you go to the members of this element filter class, you will find that it cannot be instantiated because it is created to require you to go more specific in which kind of element filter you need. So I searched through all of these filters and I found that the best filter that we can use is the element slow filter. And let me show you in the code so you cannot be confused, because I know it is confusing. We're going to create an element filter type element that is going to be our graphic style filter. You would say that name is so strange. What did you give it this name? I give it this name because this is the name that you are going to find inside of this element. When you search for the internal properties of this element with Revit lookup, you will see that this is a graphic style. So it doesn't matter, it's just the name of the container of this filter. And we are going to create a new, but now we're not going to make a element filter. We're going to actually make an element filter, I'm sorry, but of a specific kind. So let's look for the kind of filters that we can use. I'm going to find for a element slow filter, and inside of the element slow filters, I'm going to find a filter that is useful to distinguish lines based on this parameter. You can see, right? This parameter distinguishes internal from external. So I want to filter with a parameter. This is going to be the first thing that I'm going to take in mind. I want a parameter filter. And when I look in here, I can notice that actually I have a parameter filter. This is excellent. So this is the one I need. And when I search for this parameter filter, I can see that it is actually I can instantiate this filter. So I can create this filter. So let's do it. Let's create a new element parameter filter. So this is what I need. New element parameter filter. Excellent. We have it. We're all well, we're not almost ready, but we have it here. You can see that we say that we are going to create an element filter, but we created an element parameter filter because this is actually an element filter, but it is more specific. Now we have to pass in an argument, a parameter, so the filter can be successfully created. And it says here that we have to pass it a filter rule. So what is a filter rule? When you see here, you find the same phenomenon. You have a filter rule class, but actually that class is not, you cannot instantiate that class. You have to find a specific kind of filter rule. So I find I look for each one of these, and I found that the correct one to use is the filter string rule. So I think that I used filter value rule, and when I enter in filter value, I find that again I have to be more specific. I have to go further. I have to go down in the chain. I have the option of numeric value, but as I can notice that this is a string, this is not a number, this is a string, I'm going to prefer the filter string rule. So this is what I am going to create over here. I'm going to copy this and I'm going to paste it. What is going to be the filter rule in my element filter? Okay, I'm going to say my filter rule is going to be a new filter string rule. And it's going to again ask me for some parameters over here. It's going to ask me for 3 things to create this filter rule. And you can say, oh, this is annoying, but it may be, but it's also very interesting. When you find here filter string rule, you go to its member, you see that it can be constructed with this. It can be instantiated with this constructor. This constructor takes 3 elements. it takes a filterable value provider. This is the part of the filter string rule that will give you the actual value. This is what is going to take the parameter of the element and give you the value of the parameter. So let's start with this first, one. Filterable value provider. When you look for it, you can see that it has to be more specific. You cannot create a filterable value provider, but you have to search for a parameter value provider. When you enter inside of this, you can see it has a constructor. So you are going to create a parameter value provider. Let's go back and you will say new parameter value provider, and it asks you for an element ID. So you will have to say new element ID, and let's see what it asks in the Revit API. Element ID, but notice it is not any element ID. It's the element ID of the parameter. It's a parameter ID. So let's find what is the ID of that parameter. Let's go to Revit. Let's go to a line. We're going to use the Revit lookup add-in, and we're going to snoop that selection. We find that it is a model line, and we're going to find its parameters. Here we find the graphic style parameter of the line. The line style, line style. And the parameter of the line style, the ID of the line style parameter is this one. You copy it and you go and paste it over here. Here, you paste it. Now we have our parameter value provider. Here we are achieving that this script gives us the value of this parameter, the parameter with this ID. That actually is the parameter line style, that is this one that can differentiate in between internal and external. This is perfect. We are very good right now. So let's go back to the documentation. Now we have already the parameter value provided and we have the element ID. Now we need a filter string rule evaluator. Let's go to find it, and here we see that we have to choose between many filter string rule evaluator. We are going to find for this one equals filter string equals. What this says, we're going to see that we can instantiate it. What this says is that the value that comes from the previous filter has to be equal to the string that we're going to pass in. Let me explain with the code. This is going to be the second parameter of our filter, and we're saying over here that we're going to create a new filter let me check the exact name so I don't confuse you. We're going to create a new filter string rule evaluator, but more specific, a filter string equals. That's what we are going to create, a filter string equals. So back to Visual Studio, we create a new filter string equals, and we are missing one more parameter. In the Revit documentation, we see that we needed a filterable value provider, a filter string rule evaluator, and a string. Here it says the string is the user supplied string against which strings from a Revit document will be tested. What this means is that this is the actual text that you are going to be searching. It says here that it has to be equal to the text that comes from the line style parameter. Perfect. And what is going to be the text? Well, this string that we are going to store in here. I like to store it in a string variable, so we can change it from internal to external after. So I think that we are already set up. We only have to grab the filter and give it to the filter element collector. And now we should have only 19 lines because we're only filtering the internal lines. So let's see. Let's see if it works over here. Perfect. Let's call, and here you see 15. There are less lines than what I thought. Maybe I had another lines over there. But let's try. Well, we are filtering 15 red lines. Let me count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 13, 14, 15. I don't know. I think that we have more than 15. Let us see. Let's select them by hand. It says here that we have 15 lines. We have here 11 lines. Here we have 14 lines, and here we have 18 lines. So I already noticed what is the problem. The problem is that I typed incorrectly the layer in AutoCAD. You see, it is retrieving the 15 lines that are well written. But the solution to this is simple. I only have to spell correctly the parameter in here. Here it says interior, and I don't know actually. Of course. Here it says interior. It should say here it should say internal. So when we say internal, we enter that and we execute. We will have 19, not 15. Yeah, we're correct. This is perfect. Now back to our Revit. We already can collect the lines. So let's try. If we exterior, external, we will have here the same problem. We can change this to external. This should be external. Let's try the script with changing this. Let's see external inside of internal. So we can select the green lines. We should have more than 19, I think. We should have 20. At least run it. Yeah, 20. Perfect. We're okay. So let's go to the next step of our Revit, of our C# script. Now, actually, we're going to create the walls. So let's open a space over here and let's pay attention. This is very interesting. The first thing that we're going to make is a using statement. A using statement will allow us to encapsulate the code that we are going to put inside of a transaction. As you well know, you cannot create any element in Revit and save it in the document, in the file, if you don't use a transaction. A transaction is a writing in the document, in the file, in the Revit database. I'm going to call this transaction TR, and I'm going to say new transaction, and the arguments is the document and the name of the transaction. Create walls. Perfect. And here I am going to say to the script, you are going to start the transaction. And I'm going to say at the end, you are going to commit the transaction. This is to save actually the change. And inside of that, I am going to first of all, I am going to extract a line. Let me explain you this in in a detailed manner. Let's see. I am going to work from the end to the beginning because it's easier to understand it in this way. We're going to search for the wall class. When we find the wall class and we find its members, we find that the wall class has a static method called create. It actually has a bunch of creating methods. It has, this method is overloaded. It has 5 ways to create a wall. We're going to use the more complex one because it allows us to make the most of the settings of the wall. So let's see how a wall is created. To create a wall, we need the document. We don't need to instantiate the class because it's static. This is a static method. We need to pass in the document. We need a curve, a line in the Revit database. We need the wall type ID. We need the level ID, and we need the height, the offset of the level from the level, the height, the total height of the wall. We need to specify if the wall is flipped. This is what happens when we press the space bar when we are creating a wall. And we have to specify if the wall is structural or not. So when you see what we need every one of these elements, you will see the other things that we have to pass in. So let's start from here. I will copy everything in here so I don't have to rewrite it. I will paste it over here. This is awful. Okay. I need to pass in all of these arguments. What is going to be the document? Oh, I already have it saved in this variable. I will say only this. Wall create. This is the way that you have to put it. Wall create. It is a statement. I have to pass in a curve. I'm going to delete this. I need to pass in a curve. I need to pass the wall type ID. I need the level ID. I need the height. I need the offset. I need if it is flipped or not, and I need to specify with a boolean if it's structural or not. So let's go from what we already have. It's going to be structural, false. It is a boolean, right? False. It's going to be flipped. False. It's not going to be flipped. What it's going to be, its offset. Its offset is going to be 0.2 meters, 20 centimeters, and its height is going to be 4 meters. Now we have all of these this excellent result. We only need 3 more things, but actually these are the most difficult things to get. So I'm going to say to you what is the manner that I found to get the geometry of the wall, because here is a very complicated way that the Revit API creates the walls. When we collect the walls, we collect model lines. You have to have that very clear in your mind. You collect model lines. Let me show you. I'm going to comment this code over here in order to show you. I'm sorry, I know that this is making the tutorial longer, but you are really going to profit for if you don't know this. I'm going to grab the first wall and then the first line, and then I'm going to say something like get type. I mean, I am asking what kind of thing are you giving me? I know that it is a line, but I don't know specifically if that line is a curve. So I'm going to ask it, what kind of thing is this line that you are giving me? So I'm going to compile the script. I'm going to execute it. When you execute it, you find out that it is a model line. This is very important because a model line is not a curve. So you will find that you cannot create a wall with that line that you get in here because it is a model line, and the wall create method asks you for a curve. So now you need to get a curve from a model line, and that is complicated. And the method that I found to do that, I found it on the Autodesk forums, and this is the method. You have to create a location curve. This is the way, and I'm going to call it imported line location curve. Perfect. And I'm going to say the element in the line collector element at 0. For example, we're going to work only with that. I want the location of that, but you are going to convert this as to a location curve. You see it? I'm going to get the location of the line, but I am going to convert it to a location curve. You will say, this is crazy, what would you do that? And well, I ask the same thing, but it seems that this is a simple way to convert a model line to a curve. Really, believe me, if there is another method, I really would appreciate that you could write it in the comments. And then you are going to create the actual curve. I'm going to call it imported line curve. It is to say the curve extracted from the imported line. So I'm going to call the previous location curve, and I will say, give me the curve of the location curve as a curve. Convert that thing that you are giving me to a curve. And in this way, I already have the curve. This is excellent. I have the second argument of my function. Now I need the wall type ID. This is very important because you can pass in any kind of wall. So I'm going to go to Revit. I'm going to create any wall that you want. You're going to create a wall. For example, we may want to use this exterior render, and we're going to say no, realistic. Nah, I'm sorry. This is going to be a bit slow. No, I want shaded, and I want fine. Okay, here is the wall that I want to use. This is perfect. It is a bit thick, but well, this will work for now. Maybe this one. Yeah, this is less. This is thinner. Okay, perfect. So we're going to select this element, and with Revit lookup, we're going to snoop the selection, and we are going to find the ID of this type. The type, get type ID. When we enter in here, we find the ID of the wall. We copy this ID. Remember the path that we followed. You go to the wall, you go to get type ID, and there inside of get type ID you find the ID. You copy it, you go to the script, and you will say new element ID, and you pass in the number. Okay, now we need the level ID. So let's search for that level ID. Here I'm going to go to a 3D view so I can get the level. Okay, I have here the level. I'm going to go to Revit lookup, snoop selection, and I'm going to find the ID of the level. Here it is, level ID. I'm going to write new element ID, and you pass in the value. So we already have here all the arguments of the wall created. We extracted the location curve from the location of the wall, and we extracted the curve from the location curve. And that is our curve. We have the wall type ID, we have the level ID, we have the height, we have the offset, we have the is flipped boolean and the structural boolean. So I'm going to save, I'm going to compile, I'm going to go to the Revit, and let's see if it creates the wall. Run, and there is our wall. You can see, there is our wall. This is excellent. Our wall is created. But you can notice that we already create the wall, but we only have one wall, right? This is a problem because we need to create, let's see, we need to create a wall for each line. I'm sorry, I think that this is not going to be, yeah, consistent colors. We need a wall for each line. So this is very simple in these steps. We're just going to locate all of these set of steps inside of a for loop. This is going to repeat the process for each element in the collector. If we collected 100 walls, this is going to create 100 walls. I'm sorry, I said it wrong. If we collect 100 lines, it's going to extract 100 curves and create 100 walls with that 100 curves. So this is the final step. Integer c equals to 0 as long as that counter is less than the line collector. Sorry, that the line collector count. This is saying that as long as I have more lines, I will continue to repeat and go further. Count, I'm going to increment the counter. Okay, I will put all of this code inside of curly braces, and this is I'm going to pass this variable that is the counter to the location curve searching. Why am I doing this? Because when the counter changes to 1, it's going to move to the next line that I collected. When this changes to 2, I'm going to select the line located at the 2 index, at the index number 2, and so on. So this should create all the lines, all the walls. This should create as much walls as lines I have in the project. So let's try it. I'm going to delete this so you can see it. I'm going to execute the script, and there it is. You can see it. This is awesome. You already created all of these walls. And let me show you another thing that is very interesting. Look over here. We selected what kind of lines? External. So if we change this to internal and we give it another height, let's say 7, so we can differentiate, and we compile, we will see that when we execute the script, we should create walls in the internal lines. You can see it, right? This is a very powerful script. And I know that it is imperfect, it is simple, it is a bit, I don't know, you can improve many things, but you can see the power. So I think that this tutorial is useful for you, and I hope that you continue to learn and to practice Revit API C# scripting. Thank you for watching. If you like this video, please like and subscribe, and you will help very much my channel and work with that.